Welcome to Astronomy Daily, your daily dive into the cosmos, where we bring you the latest and greatest from the world of space and astronomy. I'm Anna.
And I'm Avery. We've got a packed show for you today, covering everything from the UK's first orbital launch license to a fascinating crowdsourcing challenge from NASA, and a look at a very busy week in launches.
Plus, we'll discuss the unfortunate end of a promising lunar mission. So buckle up because we're heading out among the stars.
First up, some big news from the UK space scene. British company Skyrora has officially secured the first ever launch license from the UK's Civil Aviation Authority. This is a huge milestone for them.
It really is, Avery. They've been granted a license for up to 16 launches of their Skylark L suborbital rocket from Saxavord Spaceport in Scotland. Skylark L is an 11-meter rocket capable of carrying a 50-kilogram payload.
But there's a bit of a hitch, isn't there? Despite having the license and a rocket ready, they're facing delays due to a lack of available launch pads at Saxavord, potentially pushing their first UK flight into 2026.
That's right. Alan Thompson, Skyrora's head of government affairs, mentioned that they were told there's no longer availability at either of the pads. It's quite a setback after the long licensing process.
And speaking of that process, Thompson noted it took longer than anticipated, but he understands it's an industry first and prioritizing getting it right over doing it quickly, which makes sense, especially in space.
Absolutely. This Skylark L rocket, while suborbital, is designed to de-risk technologies for their much larger Skyrora XL, which aims to put 315 kilograms into low Earth orbit. They're already making good progress on the XL stages, with integration tests planned for next year.
It's interesting to see how these smaller suborbital flights serve as crucial test beds for research. And Skyrora is also seeing rising demand for Skylark L's ability to provide up to 6 minutes of microgravity for experiments, at a fraction of the cost of an orbital mission. That's a nice secondary market they found.
It highlights the growing ecosystem around space launches, beyond just putting satellites into orbit. But this pad availability issue at Saxavord seems to be a recurring theme. Germany's rocket factory Augsburg, or RFA, also postponed their maiden flight due to a launch pad explosion. Scotland-based Orbix is also aiming for a launch from Saxavord this year, though they're still awaiting a license.
It sounds like Saxavord is going to be quite the busy hub once those pads are available and the infrastructure is settled. Hopefully, Skyrora can secure a spot soon and continue paving the way for the UK's domestic launch capabilities.
Moving from future launches to the very recent past, what a week it's been for rocket launches. Avery, give us the rundown.
It certainly has, Anna. We had a packed schedule, especially from the US. But let's start in New Zealand. Rocket Lab continued their impressive cadence with the launch of an Electron rocket.
The Harvest Goddess Thrives mission, right?
That's the one. It successfully launched a 100-kilogram Earth observation satellite for a Japanese company called IQPS. This was Electron's 11th mission of 2025 and its 69th overall, a truly rapid launch cadence.
That's an incredible pace for a small launch provider. Electron is known for its unique electric pump-fed Rutherford engines, which are largely 3D printed. Very innovative design using carbon composite construction for its stages.
Absolutely. And then, as expected, SpaceX had a busy week with 4 scheduled launches, 3 of which were successfully completed. They had 2 Starlink missions and 1 mission for Amazon's Project Kuiper.
The Kuiper mission was significant, KF.02 carrying another 24 Kuiper Internet satellites into low Earth orbit. This was the second time a Falcon 9 has launched per Project Kuiper, following an earlier Atlas V launch.
That's right. The booster, B1091, was a new one, making its first flight and successfully landed on a drone ship. It just shows the continued scale and efficiency of SpaceX's operations with their reusable Falcon 9s.
And the Starlink launches just keep coming. We had Group 17-4 from Vandenberg, putting 24 satellites into a sun-synchronous orbit, and Group 1020 from Cape Canaveral, with 28 satellites for insertion into low Earth orbit.
What's notable there is the boosters being used. B-1093 on the Vandenberg flight was on its fifth flight, and B-1085 on the Cape Canaveral mission completed its 10th flight. That reusability is truly astounding and sets a new standard for operational efficiency.
It really is. It demonstrates the maturity of their reusability program. And finally, a big one from United Launch Alliance. Their new Vulcan rocket had its first launch of 2025, which was also its third mission in total.
Indeed, the USSF 106 mission, which included a classified Space Force payload and a navigation technology demonstrator called NTS 3, this was Vulcan's first U.S. national security mission, an intricate marathon lasting over 7 hours to deliver two satellites more than 22,000 miles above Earth.
Vulcan is ULA's answer to the heavy lift market, powered by twin BE-4 main engines, and in this mission's VC-4S configuration, four side-mounted GEM 63XL solid rocket boosters. It's exciting to see ULA ramping up operations with their new flagship rocket.
A truly diverse week in space, from Earth observation to global internet constellations and vital national security missions. The pace of launches just keeps accelerating, pushing the boundaries of what's possible in space. Now for something a bit different, but just as exciting, NASA is literally calling on the public to help design the wheels for their next generation of lunar vehicles.
I love this. It's called the Rock and Roll Challenge, and they're inviting engineers and innovators from around the world to develop a lightweight, flexible, and long-lasting wheel and tire system capable of navigating the moon's harsh terrain.
The moon's terrain is no joke. We're talking extreme temperatures, craters, boulders, steep inclines, and that super abrasive ultrafine dust called regolith. Traditional rigid wheels just won't cut it for the long-duration Artemis missions NASA is planning, especially at higher speeds.
Exactly. They need something that can handle higher speeds and absorb impacts, going beyond what current rover wheels can do. The goal is to support sustained surface operations and reliably transport payloads across the challenging lunar surface.
And there's a real incentive for participants, with up to $150,000 in prizes for the most promising designs that meet NASA's technical and performance criteria. This is a fantastic example of crowdsourcing solving real-world space technology problems.
We've seen NASA do this successfully before with things like space food and radiation shielding. It really taps into global ingenuity. Submissions for detailed concepts for wheel tire assemblies are due later this year, and they need to prioritize durability, flexibility, low mass, and resistance to lunar dust infiltration.
And minimal maintenance, which is crucial when you're operating on the moon. Finalists will even get a chance to test their designs in simulated lunar environments next year, mounting them to NASA's Micro Chariot ground test unit and testing them up to 15 miles per hour.
That's incredible. Imagine your design being integrated into future lunar rovers or even influencing designs for Mars and beyond. These next-gen wheels will be essential for everything from lightweight transport vehicles ferrying astronauts and supplies to robotic rovers, cargo haulers, autonomous construction vehicles, and specialized equipment like lunar drills.
As NASA pushes forward with its Artemis missions, aiming to return humans to the moon and establish a sustainable presence by the end of the decade, reliable mobility systems are absolutely critical. This challenge is a direct response to that need.
It's inspiring to think that everyday innovators could contribute to humanity's return to the moon. Over 150 innovators have already signed up to participate in the challenge, which really shows the enthusiasm for these kinds of open innovation initiatives. If you'd like to get involved and find out more, I'll leave a link in the show notes for you. But Wouldn't it be cool if an Astronomy Daily listener won the competition? Now, for a more somber note, NASA's Lunar Trailblazer mission unfortunately has officially ended without achieving its primary science goals.
Yes, it's really disappointing news. The small satellite was designed to produce high-resolution maps of water on the moon's surface, where it is, what form it's in, and how it changes over time. This data would have been invaluable for future robotic and human exploration of the moon.
The mission launched on February 26th, sharing a ride on the second Intuitive Machines robotic lunar lander mission, IM-2, aboard a SpaceX Falcon 9 rocket. They established communications shortly after separation, about 48 minutes after launch, but then lost contact the very next day, on February 27th.
And despite extensive efforts, including help from collaborating organizations around the world who volunteered their assistance to listen for its radio signal and track its position, they were unable to reestablish two-way communications.
The limited data they did receive indicated the spacecraft's solar arrays weren't properly oriented towards the sun, causing its batteries to become depleted. Ground radar and optical observations indicated Lunar Trailblazer was in a slow spin as it headed farther into deep space.
Nikki Fox, Associate Administrator for the Science Mission Directorate at NASA headquarters, noted that NASA undertakes high-risk, high-reward missions like Lunar Trailblazer to find revolutionary ways of doing new science.
It underscores the inherent risks in space exploration, especially with these lower-cost, small satellite missions like Lunar Trailblazer, which was part of NASA's Simple X competition. They accept a higher risk posture to test pioneering approaches, which sometimes, sadly, don't pay off.
It's a tough lesson, but as NASA emphasizes, the knowledge gained from a mission like this, even in failure, helps reduce risk for future endeavors. The team put in months of effort trying to regain contact, but eventually it drifted too far for its telecommunications signals to be strong enough to receive telemetry or command.
While the mission didn't reach the moon, the two science instruments developed for it, like JPL's High Resolution Volatiles and Minerals Moon Mapper, or HVM3, and the University of Oxford's Lunar Thermal Mapper, are world-class, and that technology isn't lost.
That's the silver lining, isn't it? Bethany Ellman, the mission's principal investigator at Caltech, highlighted that the collective knowledge and developed technology will cross-pollinate to other projects. In fact, an instrument with an identical spectrometer design to HVM3 called UCIS Moon has already been selected for a future lunar orbital flight opportunity.
So while Lunar Trailblazer itself couldn't blaze its trail, its legacy will certainly contribute to our understanding of lunar water in the future. It's a testament to the perseverance of the scientific community in the face of setbacks.
And that brings us to the end of another fascinating episode of Astronomy Daily. It's clear that whether it's challenges in launch infrastructure, the sheer volume of rockets heading to space, or the ingenuity required for lunar exploration, the universe never ceases to amaze.
It truly doesn't. From the UK's first launch license to crowdsourcing moonwheel designs and the critical lessons learned from every mission, successful or otherwise, the journey of space exploration is always moving forward.
Thanks for joining us for Astronomy Daily. We hope you enjoyed our look at the latest space news.
Be sure to tune in tomorrow for more updates from beyond our world. Until then, keep looking up.